Thanks everyone for coming. I know we are probably one of the sessions that is holding you between now and the fun party today evening. So without further ado, let's get started. Let me start by introducing myself. I'm Rajiv Srinivasan. I'm an AWS solution architect, and I work with a lot of customers moving their website traffic onto CDNs like CloudFront. And I also focus on big data analytics, and that's also another favorite field of mine that I have, or a passion that I have for. And then I have with me.
Yep. My name is Joseph Pelle. I'm a software development manager in CloudFront, based out of, my team is based out of Vancouver, BC. Nobody's cheering, okay. My team was responsible for a lot of what you're going to see here on the CloudFront side, developing the reports and the analytics, and delivering the access logs to your S3 buckets.
Hello, everyone. My name is Sai Shiparasa. I'm a senior consultant on the professional services team at AWS. I focus on the big data and security.
Cool. Thanks, guys. So without further ado, let's get started. Just by show of hands, how many of you here are web developers or web engineers? Any web developers, web engineers? Cool. And any data analysts or data engineers in the house? Okay, so we have a few. Cool. And how many of you here are already using CloudFront? Okay, quite a few. Cool. So today, in this session, we're going to kind of provide a serverless framework whereby you can analyze your CloudFront access logs that will get delivered to your S3 bucket. And in this architecture, the architecture that we're proposing will actually be able to scale up to terabytes of logs per day. So it's for a large data set that you can actually analyze and gain deeper and actionable insights. And today, we're just going to jump into a few scenarios with our analysis architecture. And one thing that we're going to definitely deep dive into is bot detection and mitigation scenario. However, hopefully, you can take that architecture and you will be able to extend that to other needs that you have. For example, you can power your dashboards for being able to monitor your traffic coming in, or even able to have alarms and custom reporting as well. Nowadays, it's really common for web servers to be fronted by a global content delivery service like CloudFront. So customers use these kind of or type of front-end acceleration to fast accelerate the delivery of their websites, APIs, static content like media assets, and this is all done to make sure that your customers have an enhanced and rich experience on your platform. And at the same time, no matter where they are in the globe, they're able to access your website with reduced latency. And here are some of the challenges that we have. And by analyzing the CloudFront logs, these are some of the challenges that you can easily mitigate. For example, reducing website latency, right? So by knowing what are the popular objects or what are the popular web pages that your customers are visiting, you can get that information from the logs, and then based on that, you can make sure that those content are cached closer to them. That way, they can access them much faster, rather than having to experience the latency of going all the way towards your data center. Content optimization is another big challenge. Nowadays, customers or your users use multiple form factors. Right? They may be using tablets or browsers on the desktop, phones, and even within phones, there are multiple browsers that are there: Android, iPhone, iOS, others. And so, with these different kinds of browsers, being able to provide better experience on all of them, or on a subset of them, basically when you know that here are my hottest browsers, or here are the ways that users are actually coming and visiting my website. So you can do content optimization. So in these access logs, there is a user agent string that comes out, and with the user agent string, you can figure out what kind of devices that they are using. And Sai will cover more on the bot detection and mitigation. So before we kind of jump into this, the framework, I would like to provide a primer or introduce all these services that we are using as part of this architecture. So first, to start with, is of course CloudFront. So using CloudFront's 107 point of presence in 55 cities across 24 countries, now your application can deliver the availability, scalability, and performance for all of your customers in different parts of the world. With CloudFront, you also benefit using, it's seamlessly integrated with a managed DDoS protection service called AWS Shield. And you can deliver your APIs or your application via SSL and TLS. That way you can now secure your APIs. And CloudFront also deeply integrates with some of the services that you might be already using, like Amazon Simple Storage Service, like Amazon S3, Amazon EC2, or Elastic Load Balancing. And these resources, you can use them as your backend resources in your origin. And with DNS, like Route 53, you can speed up DNS resolution so that the request from your users to the applications are routed to the closest POP. And also, the other thing is CloudFront provides seamless integration with AWS Lambda. So what that means is now you can run your own custom code or custom logic across the AWS global network without having to provision or monitor servers. And you can further accelerate your APIs because now CloudFront also integrates with Amazon API Gateway. CloudFront can be used to accelerate both your dynamic and static content. Dynamic content such as PHP pages, or static content such as your images or your audio stream, or it could be your video stream or other software downloads. By default, CloudFront provides a multi-tier cache. So what that means is that now if you can cache your objects much closer to the user, thereby not only lowering the latency, but also lowering the load on your backend servers. So you have enough resources, and it's also cost efficient for you. For dynamic content, CloudFront can also help. The way it helps is using, you're able to do your initial TLS termination closer to the user at the POP. So now for the initial handshake, the traffic doesn't have to flow all the way from your user's browser to your origin, which could be far, far away from the user. Rather than that, now it'll terminate the connection much closer to the user, thereby reducing latency. In other cases, it also helps with having where it routes your traffic or your user's traffic via the AWS backbone. So that even further accelerates your dynamic content. The next is it also persists a TCP connection between the POP as well as the origin. So by connection reuse, you don't have to continuously reestablish connection between your user's browser and to your origin. And yes, you can front your web servers and your applications running on your on-premise using AWS, using Amazon CloudFront at no additional charge, and get all the benefits that CloudFront provides. Next, let's look at AWS WAF. CloudFront also seemingly integrates with AWS WAF. WAF is a web application firewall, and also with AWS Shield Advanced. And these can help you protect your applications from far more sophisticated threats and DDoS attacks. You can actually throw in the template. So with WAF, you can throw in a template that contains a bunch of WAF rules that best fits your needs. And with that, you can now block your common threats, such as cross-site scripting, SQL ingestion, or HTTP floods. You can also block IP addresses based on rate limits. For example, let's say a bot is hitting your website from a particular IP address, and you can now set a rate or a limit. And once it exceeds the limit, or the number of requests exceeds the threshold, now it can start blocking that IP using AWS WAF. You can also block IPs that are continuously sending you bad requests, because now your resources or your backend servers are overloaded by just sending 4xx response back to bad requests. You can take care or block those up front in the edge rather than the traffic having to flow all the way to your origin. So let's kind of dive a little bit into how the access logs are being delivered to your S3 bucket. This is important because for your analysis on how you want to analyze. So this is kind of key. So when you're in this diagram, you see two websites, website A and website B. So when a user sends a request to a website A or website B that are on that you have configured on two different distributions. So based on the URL and the DNS lookup, it's going to resolve to a particular edge location. So once it hits that edge location, what CloudFront does is CloudFront captures some of the metadata, and then it writes to a log file. And these log files are one per distribution. So it will write to a log file per distribution. So, and then periodically, CloudFront will deliver those log files into your S3 bucket that you have configured. And once the files are being delivered, then CloudFront will start another file, and then the subsequent request will be logged into the other file. Few other things to note about the CloudFront access log. So the file format is kind of important. When you're analyzing, it's important to understand. So the file format has a bucket name. It has an optional prefix that you can configure. There is a distribution ID. The reason why you have to kind of keep this in mind is if you're doing any further ETL downstream, you have to make sure that the distribution ID is actually put into the file. So you will read the distribution ID from the name of the file and then further put it if you want that information to propagate. And there is a timestamp. A note here is that this timestamp is the timestamp at which the request occurred. It's not the timestamp at which the log file was delivered to your S3 bucket. So that is key to understand for the analysis. And finally, two other things that I want to mention is that the log file can take up to several times. It'll be delivered several times an hour. And for a particular time period, it's possible that there would be multiple log files delivered. For example, let's say if you had a flash sale or something where your traffic just starts spiking up, in that case, you would see multiple log files being delivered for the same time period. So here are a bunch of customers that use Amazon CloudFront. Like we have Hulu in the media and entertainment, we have Supercell in gaming, we have Intuit in finance, and we have Canon in enterprise, and Amazon.com in the e-commerce. Again, I won't talk about each and every use case, but I'll kind of highlight one just for the essence of time. Slack is for most of you, I think, would know Slack, but for those of you who don't know, Slack is a company that builds messaging app for teams that integrates with thousands of popular tools and services. And Slack, by adopting CloudFront, was able to not only secure their APIs, but was able to reduce their latency by 300 milliseconds. And that's really huge for all of you who already know that, like if you're doing any kind of a e-commerce platform or app platform, reducing latency by even a single millisecond is a huge deal. now let's look at some of the services that are going to be involved as part of this architecture that we are going to propose further down. Again, all the services that you will be looking in here will be serverless. They are all serverless. So how to think about Lambda? Most of you may be knowing about Lambda, but for those of you who don't know, you can think of Lambda as a code or your custom logic or a function that will get executed when there is an event trigger. So what that means is that whenever there is a change in the resource state of any AWS service, or there's a change in the state of the data, or if you make an API call directly to AWS Lambda, then it triggers Lambda and it'll execute your code. And since it's your custom code, downstream you can interact with anything. Like for example, you can store it to a database, or if you want to do ETL, or you want to push it into Kinesis stream, or any other thing that you want to do. So with Lambda, the advantage that you have is now you can actually focus on building dynamic and modular and powerful applications. And all the plumbing is taken care by us. For example, what I mean by that is, as you will see in this architecture, when your CloudFront access logs get delivered to the S3 bucket, right? And a put into the S3 bucket will actually invoke your function. So what that helps is, now let's say that you have a flash sale and a lot of access logs are getting delivered to your S3 bucket now, then your Lambda will automatically scale for you to perform ETL on each and every file. And when the flash sale ends and automatically the number of logs in the S3 bucket goes down, Lambda will not be invoked, and you're not paying for anything that's idle. Next, let's look at Kinesis stream. Kinesis. So within Kinesis, we have 3 flavors: Amazon Kinesis Stream, Amazon Firehose, and Kinesis Analytics. So Amazon Kinesis, so in this diagram, as you can see here, with Amazon Kinesis, you have something called, that's on the left-hand side you see, is a Kinesis producer, right? We have 2 libraries. One, we call it the KPL library, and there is also a Kinesis agent. So using these, now whatever log files get generated, you can actually push them into Kinesis stream. And on the other side, now you can process the data that's being sent into the Kinesis stream using either third-party applications such as Storm, Spark, or there is also a library called the Kinesis Client Library. You can use that to read the data off of the Kinesis stream and then further push it down for visualization or downstream analysis. With Kinesis Client Library, you can do ETL as well. With Kinesis has this concept called shards. And in a shard, the throughput is, like, your input can be 1 megabyte per second, and your output rate can be 2 megabytes per second. So, and if your throughput is much more than what you need, now you can increase the number of shards and lower the number of shards. And with that, you can adjust and scale to the throughput that you need. The next one I want to introduce is the Amazon Firehose. So when we introduced Kinesis, we saw that a lot of customers were actually, running the KCL or the KCL library to kind of move their data from the stream to a persistent data store. So what we thought was, why don't we do this heavy lifting for our customers? So that is when we built what is called as Kinesis Firehose. So with Kinesis Firehose, now you can actually push the data to S3, Redshift, or Amazon Elasticsearch. So these are the 3 targets that we provide. And then you can do your downstream visualization and analytics. So here is an example of Kinesis Firehose pushing data into S3. So within Kinesis Firehose itself, you can do transformations as well. So within Kinesis Firehose, you can invoke a Lambda function that will do the transformation for you. And Kinesis Firehose also buffers the data. So you can have a buffer between, like it can buffer your data between 1 to 128 megabyte, and also you can specify a buffer interval. So whichever it hits first, let's say if you specify a buffer interval of 3 minutes, or if you specify a buffer interval or a buffer size of, say, 2 megabyte, whichever it hit first, based on that condition, it'll get triggered, and your data will be getting delivered to your target. And if there is any error, for some reason, there is an error in your transformation code or anything, in that case, it'll automatically be delivered to a backup bucket. And the file format is what is below. So it's kind of a time series data that's going to get delivered. And this is really good for further downstream analysis. The next one we're going to look at is Amazon Kinesis Analytics. So we saw two. One was Amazon Kinesis Streams and Amazon Firehose. So now, as data is coming or moving through these Kinesis Streams or through Kinesis Firehose, now you can run your SQL query on top of Kinesis. And then, based on those analytic queries, the results can be, again, pushed to another stream for doing visualization. And Kinesis Analytics will automatically scale for you, and you don't have to deploy any servers for doing analysis. And just to say, all the services that we're talking about, all are serverless. And so at the end, with these, you will be building an entire serverless architecture. The next one I'm going to talk about is Athena. So for those of you who don't know, Athena is an interactive querying service, right? So with Athena, now you can actually query the data directly from S3 and be able to gain insights into the data. You don't have, so in an on-premise or in a traditional way, the way it's being done is you would spin up a Hadoop cluster or a Spark, and you would run Spark or Hive, and in order to process your data from your persistent storage. Now, with Athena, you don't have to spin up any clusters. You only pay for how much data is being scanned. So you're paying for two things: the data that you're storing in S3 or your data lake, and then the other thing that you're paying for is how much data that you're scanning. And by using partitions and other best practices that we will discuss further, now you can actually limit the amount of data that you're scanning, and at the same time be cost efficient. Next, look at Amazon QuickSight. So QuickSight is a BI tool built in the cloud and for the cloud. So, and with QuickSight, now you can analyze your data, and then you will be able to create read-only dashboards that you can share with your sales and marketing team, and then be able to generate storyboards off of that. So QuickSight connects with multiple data sources. So QuickSight has a SPICE engine. SPICE stands for Super Fast Parallel In-Memory Cache Calculation Engine. So with SPICE, now you can inject, you can actually schedule ingestion. You can have scheduled ingestion, whereby now you can get data at an interval from S3 or from a database that's running on EC2. In this architecture that we are going to propose, you will be looking at where you will be using Amazon QuickSight to query using Athena for the data that's living in S3. So if the data is in S3, you can query either using the SPICE engine, or you can, and if for a larger data set, you can actually query using Athena. And with few clicks, you will be able to connect to Athena as your data source in QuickSight. QuickSight data sources are even extended to RDS. So now you can query a data that's in a relational database, or it's also extended to Amazon Redshift and Redshift Spectrum. So in this case, where your hot data lives in Redshift and your cold data lives in Redshift Spectrum, now you can query the data directly from Redshift and Redshift Spectrum. For those of you who don't know what Redshift or Redshift Spectrum is, it is a data warehousing service provided by AWS. So kind of spoke about analysis, but analysis is also requires one more piece, which is ETL, right? So now with AWS Glue, you don't have to spin up any servers to perform your ETL. ETL stands for extract, transform, and load. With Glue, we'll actually can crawl your data that's in your data lake in S3, and it will automatically discover the schema. And not only it'll discover the schema, but it'll automatically generate the ETL code for you. So, and the code is actually generated in Python, PySpark, so you can write your Python code on Apache Spark 2.1. And it also integrates well with all the different analytic services on the AWS platform. So for a data catalog that is in Glue, it'll integrate with EMR, it'll integrate with Athena, it also integrates with Spectrum and all the other analytical tools that we have. And for those of you who don't know what a Glue data catalog contains is, a Glue data catalog contains metadata or metadata about the schema, the location where the data exists, and as well as it contains information about the partition. Glue has 3 components. So the first one is the data catalog. As I mentioned, the data catalog is where you can, for those of you who know, it's a Hive compatible it's kind of a Hive compatible meta store with enhanced functionality. And with the data catalog, now you can crawl your data in S3. And these you can, let's say if you have a proprietary format, now you can crawl the data automatically and extract the metadata. So if you have a proprietary format, then you can write your custom crawlers. But for all the other open standards that are there, Glue will automatically discover what the schema is. And then now you can author and execute ETL jobs. So you can schedule ETL jobs, or you can even author jobs using Glue. And you don't have to spin up a single server for any of this. So what essentially happens is with this framework, with using these services, we have built an end-to-end data analytics pipeline, whereby now when your CloudFront access logs get delivered to your S3 bucket, now you don't have to spin up servers, you don't have to monitor servers, you don't have to hug your servers. So, and you will only pay for what you query. So with that, I'm going to hand it over to Joseph.
All right. Thank you, Rajiv.
Thanks.
So, it's kind of loud. So now you guys have a good overview of CloudFront. You have an overview of our access logs, a brief overview of our access logs, and a good overview of the different Amazon and AWS services that will allow you to build a serverless reporting and analytics pipeline. I'm going to give you a little bit of a deeper dive into what CloudFront provides out of the box based on these access logs. And from that, hopefully you can get some idea of how you can leverage the data that's in the access logs for your own benefit. So out of the box, Amazon CloudFront provides 5 reports for you. These reports are designed to provide some insight into the viewer requests that are landing on our edge locations and are intended for your application or your service. 4 of these reports are based directly off of the access logs themselves. The access logs are the raw data. The 5th report, the usage report, actually shares a data source with the AWS usage report that can be found in the billing console. So, where the access logs are generally available to you in your S3 bucket about 10 to 15 minutes after the request lands on an edge location. These reports are available for the last hour, going back 60 days. So they're available in the console, in the reporting, the CloudFront console for the last 60 days. The intent of these reports are to provide you with an accurate historical view of your service or your application and the viewers that are using this, your customers. If you do want to maintain this data, to persist this data for longer, you have a couple of different options. The first is that you can export this to CSV, and you will get exactly the data that we have in the reports. And the other is, of course, the access logs themselves. You just turn on, you enable your access logs in the CloudFront console, and they'll be delivered to the S3 bucket of your choice. CloudFront also provides you with 6 operational metrics. These are near real-time metrics that are intended to give you a right-now view of what's happening in your service. For example, using the 1-minute granularity for these metrics are available to you about 2 minutes after the request lands on our servers. 1 minute to aggregate the data and 1 minute to ship it to CloudWatch. These metrics are available in the CloudFront console and the CloudWatch console. And we monitor things like requests and your bytes downloaded and your error rate. Because it is a CloudWatch metric, you get all the benefits of CloudWatch as well. So for example, you can set alarms on these metrics and have them, when they exceed a threshold, have them notify you through something like SNS. And that will allow you to react to the events that are happening on your service right now. The idea behind all of this is for operational monitoring. Whereas the metrics are meant for operational monitoring, the reports that I talked about are more for that operational analysis. They do ultimately share the same data source. It's the requests that are landing on our hosts and are intended for your application. So here you can see CloudWatch on the left and our usage report on the right, and they're both showing you roughly the same information. We're showing you requests, and we're showing you data transfer as an example. And you can see that the pattern is the same. I'm showing you different granularities, which is why you get the peaks and valleys in the one, and it's a little bit smoother on the other side. Now, while they're the same, they do go through a different set of processing, and therefore there can be some discrepancies between the two in the presentation of this data. Again, one is meant for real time and one is meant for a historical view. I'd also like to point out a couple of differences. And this is where you start to see what those access logs can give you. While this is relatively a basic report, the usage report, it still gives you a bit more of a view into your service. We're not just showing you a count of your requests. We're showing you a count of your requests broken down by, for example, protocol. We've also, you can see at the top, you can see that we break this down by billing region. So now you're starting to see how you can dive a little bit further into this information. By looking at your billing region, you can see how your usage varies on the billing region, and that might help you, for example, decide on what price class you might want to use. Staying with operational analysis for a moment, here you have the cache stats report and you have the usage report. Cache stats is meant to kind of tell you the performance of the cache, and we're going to tell you about your hits and your misses. I'm using this example to show you an event that happened on October 25th. On October 25th, you see an increase in total bytes to the viewers. And perhaps you've already had a CloudFront metric, an operational metric, fire an alarm and tell you this. And now you're looking back at it and figuring out, well, what happened? Looking at these reports, you can see that you also have an increase in misses. You can see that you have an increase in 5xx errors. And this is starting to give you a sense of what you can, what information you can glean from these access logs. Taking a look at the usage report, you see the same spike. And you can start to correlate the data and tell you where to go look to find out what happened. We also have three additional reports. We have the top referrers report, which will show you the top 25 referrers, and it will show you the number of requests and how that relates to the other referrers. We have the CloudFront viewers report, which actually digs into the user agent string and to the viewer IP, the source IP addresses. And this is going to be used both for an operational point of view and also for maybe a content optimization or a sales and marketing point of view, because now you are able to get a view, pardon the pun, you're able to get a view of your viewers, who they are, what browsers they're using, what devices they're using, and maybe that now you can make some business decisions about what your actual audience is, who is actually using your service. The location report uses IP to figure out where the viewers are coming from. And you can compare, our location report allows you to compare the different locations. We're going to show you the top 50 locations, top 50 countries or US states. The popular object report is a good report to get an idea of the objects, your hottest objects. We show you the top 50 popular objects, and we're going to break that down into the number of requests for that particular object, the number of hits, the number of misses, and now you can start to see what those viewers are actually looking at. I did want to caution one thing on this particular report. We show you the top 50. We track the top 150. We don't track every single one of your objects. And as such, this is an estimation. So for certain use cases, this estimation can lead to a margin of error. However, because this is all based off of the access logs, we also give you that raw data that you can use to get a perfectly accurate view of your popular objects should you choose. And that kind of leads into the next thing I wanted to say, which is that these reports that we have are just the tip of the iceberg. It's just meant to give you some kind of idea of what you can look at and what information you can glean from the data that we collect on your behalf. So how do you actually get more information out of this? And how do you turn this raw data that is the access logs into something more meaningful? And maybe you would end up using something like QuickSight, which we've described, to prepare your data and analyze it and to create some visualizations that can be used for your operations or can be used for your sales and marketing or your business execs. I'm going to show you one simple way to do this. As you saw from Rajiv's slides, we at Amazon and AWS have a lot of different tools that you can use and you can stitch together in some fashion to perform this analysis. I wanted to show you this one, which is very simple. Hopefully very simple to set up and simple to use. And hopefully you can see the benefit of that. Our access logs, as I said, are delivered every 10 or 15 minutes to Amazon S3. You can set up Glue, AWS Glue, to crawl that data source. And it's going to discover those logs in your S3 bucket. It's going to create a catalog for you. And that catalog is now available to Athena. Athena is then used to query those buckets and pull that data right out of the log files that we have there. And then because QuickSight is built on top of Athena, it uses Athena as a data source. all of that information is now available for those visualizations, that analysis that QuickSight allows you to do. And it really is that simple. And the other benefit is that it's serverless. Now, I'm hoping that you guys kind of understand the benefits, because the benefits are dependent upon your use case. Why would you want to turn this data into something more meaningful? Here are a couple of examples, but definitely not an exhaustive list. First, it's going to give you a deeper insight into your service, into your application, into your viewers than what we provide with our default out-of-the-box reports. You're going to be able to create your own customized reports, maybe dive deeper into those status codes that we have, those 4XX. We only show you 4XX. Maybe you want to see 404s compared to 403s. You can start to correlate this data. So not only are you looking into the error rates, but you're looking into the error rates and you're breaking it down per region. We give you the edge locations in the access logs. So now you can actually see how this viewer data flows through the CloudFront network. And maybe you can correlate that with viewer behavior or error rates or whatever. And then now you can start to make decisions on these correlations that you are gleaning to optimize your cache. Maybe you now discover that Firefox is the most popular browser in China, and you want to, Asia, and you want to start targeting your application for that particular viewer use case or for those particular objects. Sales and marketing can use this information to mine the viewer data that we provide and to mine the geo data to really get a good, deep understanding of who your viewers are and what they want, and maybe even what problems they're coming up against. Now, this is kind of telling you the benefits of what information is there and what you can glean from turning this data into this information. But I think that one of the most powerful things that can happen from this is your ability to take action on this information. And I'm going to turn this over to Sai, and he's going to tell you how to take this information that you've now gathered and turn it into an action.
Thank you, Joseph. Okay, so from what Joseph's already mentioned, there are multiple reports that we can focus on. Who are the top talkers? What are the most popular objects? What are my most popular pops? What sort of caching behavior do I have? So these are all good reports. I think there are more reports that we can actually generate and analyze. I personally am a data guy. So the more the data that I get, I actually start running more analysis and I'd like more insights. But for this use case or for this section, we'll actually focus on bot detection and mitigation. The idea here would be not just are we taking a look at the data, what is the easiest way to analyze the data, extract an insight, and also respond to that sort of an insight, right? So a good amount of time, maybe I actually have known users or reliable users that are actually accessing my content. But what if I actually get hit by an unreliable user or maybe even a bot? At that point, I'd really want to understand where this data is coming from, what is the pattern of access, right? So we'd actually take an approach of how simple or how can we actually simplify this sort of process rather than me as a user running a fleet of servers to detect these sort of things, be it on a batch basis or be it on a real-time or close to real-time or even an online basis, and then even build up my own incident response strategy. But before we get into the detection piece and the mitigation piece, here's a very simple example where we have a bad bot that's coming in, and we understand that this is a bad bot given that we've already identified this and maybe even labeled this. And as the data comes in, I take a look at the user agent. Once the request hits CloudFront, the request is passed to AWS WAF. WAF takes a look, at all the ACLs that are available. If the ACL says this guy is a bad guy or there's a certain bad pattern, I would take the sort of response to either block it or to redirect it. Having said that, there are multiple other ways to detect a bot, right? So there probably could be IP range patterns that we already have. There could be predefined bot signatures that we want to monitor. There could even be more convoluted bot patterns where if within a minute I have requests coming in from same bot with a same IP address or even an IP CIDR, at that point I'd actually react and start redirecting that content. So how does that really work? Users are accessing the content. The first request would always end up on the CDN. The CDN is taking the data in, the headers, and then it would pass on the headers to WAF. WAF starts taking a look at it. All this would be monitored, and the metrics are sent to Amazon CloudWatch. After a little bit of time, a few minutes, these requests start, they're flushed into logs. These access logs make their way to Amazon S3. Now, while these logs have a lot of good information, such as the date and time when a request was completed, the POP that was used to respond to this request, the HTTP access methods that were used for a certain request, the user agent, many other fields are populated via these or are provided via these sort of access logs. But I think one key element that we'd be looking for would be what is the IP address, what is the user agent, what is the date and time when a certain request was completed. Now, once these logs are delivered to Amazon S3, then we can start either preparing the logs or directly analyzing the logs. Now, 9 out of 10 times, there would be some amount of preparation that we might want to think about. Think about a scenario where I am a big customer. I actually have a lot of distributions across a region or within, or across the world or within a region. CloudFront would deliver the logs, and the file name format would always carry the distribution ID. So in this case, if you actually want to add that distribution ID to the logs, we can trigger a Lambda via S3 notification and start adding that data. Taking this further, I might even start building my own ETL transformation pieces into it. What if I want to build a binary classifier? Or what if I want to build a multi-label classifier where I actually look at patterns that are coming in? I already have a model that I could load up onto Lambda, and Lambda in itself would classify the data before it sends the data out. One option that we have is every record or every set of records that are flowing into Lambda can be flushed onto S3. But how do we access this data is very important. When we use either something like an EMR or an Athena or use Redshift, the recommendation would normally be understand your split size. If we actually have too many files that are being pushed to S3 and Athena has to read all of those files, at that point, there'll be multiple containers or multiple executors or multiple mappers that are actually loading and pulling this data. And the cost of building each task or each mapper sometimes would be around 5 to 20 seconds. So understanding what sort of data access patterns do we have is very necessary before we start splitting the data to disk. So as the data grows, the recommendation that we've actually noticed that helps us a lot would be send the data over to Kinesis Firehose. What Kinesis Firehose here would do is aggregate the data on a time basis. So depending on how quickly do we want to analyze the data, you could either begin from 1 minute or even go up to much larger time period, so that you actually are building these sort of time blocks, but the object sizes would actually be bigger. Once we have the data on S3, we can then start running our analysis to see what sort of patterns are we noticing. Once we notice these patterns, and assuming we actually find a certain bot pattern or an unreliable signature, at that point, the next thing would be, how do we respond to this incident? We either have to go back to WAF and use the create rule API, build an ACL, and make sure that the ACL is applied. But this sort of a batch analysis needs to be done maybe once every day, or could even be done every hour, depending on what sort of a bot traffic do we have. A question here would be, this sort of batch analysis is good, but to build a much quicker continuous response strategy, should we think a little further, and how about make it a little bit more of an online process? So for an online process or an online analysis, where do we fork the process? We have data living in Kinesis Firehose already. So how about we start running analytics using Amazon Kinesis Analytics? Using SQL or using standard SQL queries, we can now start looking at what sort of patterns do we get. And as long as we have taken enough measures in preparing the data, running SQL with Kinesis Analytics would be very simple. Once we realize that there are some bad bot signatures, at that point, our incident response strategy would begin. Kinesis Analytics can push the data into, or in this case, the outliers into Kinesis streams, and then we can trigger a Lambda against the Kinesis streams and build the response strategy. How would that look like? So in this case, we have identified that there is a bot signature. We understand what the bot signature is. It could be a combination. It could just be a user agent, or it could even be a combination of an IP address and a user agent. And this, using the Java SDK or Boto3, we can update the WAF and make a request saying that, hey, add this new web ACL, and use this web ACL from here on. Putting things together, do we have to use, if I were given an opportunity to pick between batch analysis and an online analysis, I'd probably reach a little further and say I need both, right? So irrespective of how quickly I go back and update or even analyze my data, I still would want to do some sort of batch analysis so that I can update my models if I'm using a machine learning model, or update my rules if I'm using standard SQL. The next thing would be, if there is a necessity to build a dashboard, who are the top talkers? Where are the bad bots coming from? What sort of IP ranges are we seeing? What sort of fluctuations do we see? At what point do certain bad bots hit us from a certain geo? For these, a recommendation would be to build your dashboards. They could be operational dashboards, or they could just be reports. We could either use Amazon QuickSight, or we could use Elasticsearch. While building this sort of an architecture, there are a few best practices that we have come across. And these pretty much apply even outside of this architecture, but these normally have helped us while implementing this. When it comes to data, partitioning is always a good practice. There might be a certain use case where I want to query all of the data that I have had since my app has got into production. But for certain scenarios, I just want to understand what happened in the last day, or what has happened in the last hour. For this sort of a scenario where we are charged based on how much data gets scanned per query, a recommendation would be partitioning would help here, right? So the amount of data that's being scanned would be less. At the same time, using compression, or even coming up with the right compression strategy, is another recommendation. Most of these analyses wouldn't need all the columns, where we have to scan all the columns where they actually are coming back. So thinking columnar formats is also recommended. So columnar formats such as Apache Parquet or Apache ORC is recommended. Using columnar format, we only bring the columns that are necessary, and we are not running a whole table scan or a file scan in this case. Coming to Lambda, it's always recommended to use environmental variables as we actually pass the operational parameters, say the name of the stream. It could be different from your dev to test to prod. So always operationalizing this and using environmental variables is recommended. One thing that I've personally run into while implementing this is testing it with different batches and record sizes. There have been certain scenarios where my Lambda function works in 90 odd cases, but it would fail in like a few cases. Those are the scenarios where either the batch size is pretty big or the record size or the file size would be big. So identifying what is the memory that we actually want to need or that we need is very important. Security again is job zero. So using the most restrictive permissions when setting up IAM policies, either for Lambda or for Firehose, are recommended. Finally, setting up CloudWatch alarms is always recommended. So as an example, if we have Kinesis analytics that is processing the data from either a Firehose delivery stream or from Kinesis streams, understanding what sort of input-output bytes are we processing, or even the number of records that we are processing is necessary. At the same time, understanding back pressure is also recommended. So using milliseconds behind latest is something that is necessary to track how far behind is the application in reading and processing the data. The last recommendation would be continuously monitoring or even automating the monitoring of CloudWatch alarms. Mainly when we use a combination of Kinesis analytics applications with Kinesis Firehose or with Kinesis streams. Understanding that we use the optimal number of applications with the stream is necessary, because the delivery stream is already doing a job of sending the data to a delivery target, be it S3 or Redshift or Elasticsearch, or now with Splunk, which is in preview. Putting everything together and summarizing the session, there are multiple different ways to slice and dice and analyze the logs. And by using serverless architecture, the amount of infrastructure that we end up managing would actually be lower. And also automating this sort of an environment would be easier. Yep, so that's pretty much it. Again, thank you all. Given that this being the last session, you guys have made it. We're just a little away from the replay party. Thank you all for your patience and making it to the last session. So you have a couple of minutes. If there are any questions, we'll be happy to take the questions here, or after the session, we'll be outside and we'll be more than happy to take any questions. Yeah.